All right, let's go to let's jump down to number 3 on the worksheet. This was page 26 worksheet, because there's a couple different ones. Let's go green. I haven't used green in a while. All right, here we go. Look at number 3. It says find the sine of 30 degrees. Now look, I want you to find the sine of 30 degrees without a calculator. All right, this is without a calculator. So look, here's a right triangle. Put a little right angle right there. Let's go back to green again. There we go. What we're going to do is this. Now, the book does it slightly differently. Most of you probably didn't even look in the book anyway to see how to do this, but I'm going to do it like this. This is going to prepare you. Listen, this is going to prepare you a lot for Algebra 2 next year when you do this trig stuff. You do the trig stuff at the end of the year in Algebra 2, just kind of like how we did it in geometry, right? But some of this may kick in a little bit when you're taking Algebra 2 next year. All right? Yes.
Do we have to draw a triangle for each and every one?
I would, yes.
Oh dear Jesus.
Okay. It says use a special right triangle to express. All right. So it says use a right triangle. All right. So go ahead and do that. Yeah. Don't want it. Don't want to put it in a calculator. I want to show you how to do it without a calculator. Now watch. This is a sine of 30 degrees. So that must mean we have a 30-degree angle in here, correct? So I draw a triangle that's got a 30-degree angle. So if that's 30 degrees, what's this one up here? That's 60 degrees, okay? We may not even need it. I don't know. But watch. Let's do this. Let's make our hypotenuse on all of these. I'm going to make the hypotenuse 1. All right? You with me so far? Now, you may not understand why. It's about a unit circle. Don't worry about that. Just make the hypotenuse 1.
You told us at the end of class.
I did tell you at the end of class. I wrote it on the board. You remember that?
Yeah.
And I said, right? I said, make the hypotenuse 1. Now watch. What do we know about 30, 60, 90 triangles? Let's review quickly. We know that the hypotenuse is equal to twice the what? The short leg. The short leg. Okay? And that the longer leg is equal to the square root of 3 times the what? The short leg. Do you remember that on a 30, 60, 90 triangle? Okay? So now look, this time I know the hypotenuse. What can I find very easily here if I know the hypotenuse? I can find the short side, can't I? Okay? So this is twice this. So that means the short side is what?
2.
No.
1. What?
Come on, think. If this is twice as big as this, what is this side right here? Yeah, don't give me 0.5. Give me a fraction. It's a half. All right, it's a half, right? Would you agree with that? If this is twice as big as this, if you're not sure about that, punch it into this little formula right there. Hypotenuse. What's my hypotenuse?
2 times.
No. What's my hypotenuse?
1.
It's 1 equals twice the short side, right? We'll call the short side x. How do I solve for x? Divide by 2. What's x equal to? It's 1/2. All right? You shouldn't have to go through that, but that's what you can do. Now, what is the long side? The long side is what? The square root of 3 times the short side. Well, the short side's a half.
1/2 the square root of 3.
That's right. So watch. 1/2 times the square root of 3. I'm going to put that over 1. But then let me show you a nice, easy way to write this. Instead of writing it 1/2 times the square root of 3, look what we can do. Multiply it straight across. That's square root of 3 over what? 2. Now watch. If we know this stuff right here, now that wasn't hard. We've done stuff with 30, 60, 90 triangles, okay? I just happen to tell you the hypotenuse. We've done stuff like that before. I think you've had a quiz on stuff, I think. Okay? What's complicated about it? I gave you this, right? Or I told you to make the hypotenuse 1. You find the short side. You take half of it. Is that complicated?
No.
Okay, it's not. Then if you know the short side, how do you find the longer side? You multiply it by the square root of 3. Is that complicated? Is that really complicated?
No.
I don't think so. Look, 1 times square root of 3 is square root of 3. 2 times 1 is 2. Alright? So look, I got all 3 sides of my triangle. If I want to, look, let's not just find the sine of 30. I'm here to teach a little bit more than just that. Let's find all 3 of them. Let's find the sine of 30. Let's find what else? The cosine of 30. What else? Let's find the tangent of 30, just for fun. Okay? So look, here's your angle right here. Here's your 30 degrees. Let's put in our little device. What's our little mnemonic device? SOHCAHTOA. SOHCAHTOA. All right, so watch. Let's find the sine first. What's the sine? It's the opposite over the hypotenuse. Which side is opposite? It's 1/2. Over what? 1. What's 1/2 divided by 1? It's 1/2. Isn't that the answer that you found when you put it into a calculator? Yeah, somebody put in sine of 30 in a calculator. Bet you anything you'll get a half. You get 0.5, won't you? Yep, you do. All right, so that's kind of cool. Look, we did all that without a calculator, didn't we? Kenny, with me? Wake up. Look at the cosine. What's the cosine? The cosine is the adjacent over the hypotenuse. Which side's adjacent to this?
The long side.
Okay, square root of 3 over 2. Over what?
1.
Over 1. See why I made it 1? Made it kind of easy. So watch, what do we get? Square root of 3 over 2. The thing is, you wouldn't be able to get the square root of 3 over 2 on a calculator. You'd get a decimal, right? But there's no way that you could punch in the cosine of 30 and get the square root of 3 over 2 on your calculator. It doesn't work that way. It gives it to you as a decimal. Right? But if I ask to write it as a fraction, you're going to have to figure out how to do that.
How did you get the 1/2, 2 over 1? No.
It's 1/2 over 1, not 2 over 1.
No, I was
Right here?
Cosine, but it's 2 over 1, so
It's square root of 3 over 2 divided by 1.
Yeah.
Anything divided by 1 is itself, right? So it's just the square root of 3 over 2. All right, this one might be a little bit more confusing, but let's give it a shot.
Can you use the same triangle for number 6?
Is it a 30-degree angle?
Yeah. So like you could just
Yeah,
draw
any of them with a 30, 60, or degrees, you can use this triangle. If it's 45, you're going to use a 45-90 triangle, aren't you?
Yeah.
Okay. So watch, let's do the tangent of 30 this time. The tangent's a little bit more complicated, but it's what? It's what over what? Tangent. Opposite over adjacent. So opposite is 1/2 over adjacent, which is square root of 3 over 2. Now look, don't flip out over this. When you're a little kid, you learned how to divide fractions, didn't you? What's dividing fractions? Sure you did. Let me make up a fraction. I'm just making up a normal everyday fraction. Let's do this. Divided by, remember this when you were a little kid? Divided by 7/5. All right? What if I had something like that? What was the rule for division? Multiply by the reciprocal. That's right. You remember that, don't you?
Yes.
Okay, division is the same as multiplying by the reciprocal. I'm getting shaking of heads. You never learned how to divide fractions?
I just don't remember.
You learned how to put it in a calculator, though, didn't you?
Yep.
See, that's the problem. Right, you flip the second one. Okay, so you flip it. What is it? 5 over 7. Right?
Yeah,
That cancels, and that's 3 over 7. Look, I'm going to do the same exact thing with this. This is just a division problem. See that big dividing sign right there? So watch what we do. We take 1/2. Instead of dividing by this, what do? Multiply by the what? Reciprocal. What's the reciprocal? 2 over square root of 3. Now watch. Again, don't flip out. It's a couple steps. All right? You guys freak out after we do one step. Okay? You might be good with 1 or 2 steps, but then after that, everybody flips out. Oh, I'll never be able to do this. All right? You got to be able to go from step to step to step to step. All right? If you're a little baby and you only took 1 or 2 steps, that wouldn't get you very far, would it? All right? What'd you learn how to do? You learned how to take your 3rd, 4th, and 5th, and 6th step, didn't you? Okay? That's what we're doing here. Watch. The 2's cancel out, so what do you have? You have 1 on top, and you have square root of 3 on the bottom. As far as I'm concerned with this class, if you wanted to keep it like that, I'd be fine with that. But we learned something. What did we learn? We're going to do a lot more of this in Algebra 2 next year. Yeah. So for right now, I'm okay if you just left it like this. But let's do this. What's 1 times the square root of 3? Square root of 3 over what? 3. So the tangent of 30 is the square root of 3 over 3. When you get into Algebra 2, listen, when you get into Algebra 2, all these are going to be memorized. The sine of 30 is going to be a half. That's just going to be memorized. You should... I just multiply. 1 times the square root of 3 is the square root of 3. Square root of 3 times the square root of 3, right, is the square root of 9, which is 3. Remember that? The square root of something times itself is just the number that's inside of there. Remember, we've gone through this before. Remember, what's the square root of 5 times the square root of 5? No.
5.
It's 5. It's the square root of 25,
Oh.
which is 5, okay? And watch. What's the square root of 7 times the square root of 7?
7.
What's the square root of 256 times the square root of 256? It's just 256, okay? So that's how you get that. Now look, I'd be okay if you left it like that, but just for fun, we changed it to that. Because you're going to have to eventually. Might as well learn.
Did you say this for fun?
Yes, I did.
We have some fun.
We do have a lot of fun in here, don't we? Alright, let's do one of the 45 ones. Oops. Let's make this a little bit bigger. Okay. Alright, so which one has a 45 in it? Number...
Number 4. Number 8.
Yeah, number 4. Let's just do number 4. It says find the tangent of 45 degrees. So what do? I draw a triangle that has a 45 degree angle in it. So if this is 45, what's this one up here got to be? It's got to be 45. What's the first thing I do with this triangle? I got to label it. I don't know any of my sides, but I make one up. I make the hypotenuse what? 1. Make it 1. Everybody see that? Okay. What's the rule for a 45-45?
Square root of 2.
The hypotenuse is the square root of 2 times what?
The short. Or the
There's
long.
no short. Okay, they're just the same two sides. Okay, this and this are the same. So those are your two legs. So it's the square root of 2 times the leg. If I wanted to find one of these legs, let's just call it x. If I wanted to find one of the legs, I know the hypotenuse, that's 1, equals the square root of 2 times x. What do? Divide by square root of 2. Alright, so x is, I'll tell you what, let's simplify this. I think we're getting good at this now, don't you? How do I get rid of that square root of 2 in the bottom?
Multiply by the square root of 2.
Over the square root of 2. Okay? Remember that? We just finished doing it, and you said you had it then. It's the same thing. Get rid of the square root of 2 by doing this. What's on top? That's the square root of 2 over what? What's the square root of 2 times square root of 2?
2.
It's 2, right? We went through that whole routine. Square root of 256 times square root of 256 is 256, right? Square root of 7 times square root of 7 is 7. Square root of 2 times square root of 2 is 2. Look, that's what this is right there. It's the square root of 2 over 2. What's this side right here going to be?
Times the square root.
It's going to be, no, it's going to be the same exact thing. Because remember, the two legs are exactly the same. Now, with all that done, and that's not new, is it? That's old stuff. We've done this before. The only thing new is that I made the hypotenuse a 1. We've done all the other stuff before. So now what are we going to do? We're going to find the sine of 45. I'm going to do the cosine of 45. And I'm going to do the tangent of 45. I want to do all three just so that you have good practice with this. You could use either this 45 or this one. It doesn't make any difference. What is the sine? Let's write it up here. So, ka, toa. Alright. So what is the sine? The sine is opposite over hypotenuse. Now watch how easy this is. And this is why it's nice having the hypotenuse to be a 1. The opposite is square root of 2 over 2. Over 1 is just what?
Over 1.
Square root of 2 over 2, right? Over 1 doesn't change it, does it? So that's what the sine of 45 is. As a fraction,
That's the same
not as a
for the
decimal.
cosine?
Cosine is exactly the same because look, it's adjacent over hypotenuse. Well, the adjacent side is exactly the same, isn't it?
Yep.
So the square root of 2 over 2 for the cosine of 45. Alright? Look at the tangent. The tangent's really fun. Watch this. The tangent is the opposite over the adjacent. So it's the square root of 2 over 2 divided by what? Square root of 2 over 2. What's anything divided by itself?
1.
It's equal to 1. That's the tangent of 45. Now, could you have put the tangent of 45 in a calculator and got the number 1?
Yes.
Absolutely. But that's not what this problem is all about. This problem is trying to get you to understand the relationships between the opposite, hypotenuse, adjacent, and all that kind of stuff. Okay? It's not just a matter of putting a number in a calculator. Ladies, let's sit up, please. Right here. I won't call your name. Sit up. Let's pay attention. All right? I have no idea how you could possibly put your heads down while I'm doing this because this stuff is not that easy. All right? If stuff is not that easy, I'd be paying attention more than I ever was. Not putting the head down on the table. That's ridiculous. All right. Enough of that. So there you go. If you don't understand it, you can always go back to the video, watch it tonight. Okay, I went through all the explanations of how to do those. So you should be able to do every one of those now. In fact, we covered every single one of those. All right, because we did the sine, cosine, and tangent of the 30s. Actually, we didn't do the 60, did we? But it's the same thing, right? I mean, it's the same triangle, exactly. It's the same triangle, just use the 60 this time, right? Or you could remember what we talked about. Look, the sine of 30, this is kind of cool. Watch this. The sine of 30 is the exact same value as what else? The cosine of 60. The sine of 30 and the cosine of 60 are the same thing. If you don't believe me, let's watch. Here's 60. What's the cosine? It's adjacent over hypotenuse, isn't it? Adjacent is 1/2 over 1 is 1/2. Am I right on that? The cosine of 60 and the sine of 30 are exactly, whoops, the same thing. So what do you think the same thing as the cosine of 30 is?
The cosine of, or the sine of 60.
That's right. The sine of 60 is the same thing as the cosine of 30. You guys watching? You guys are killing me.
I'm paying attention. I'm answering you.
Look, the sine of 60 is the same thing as the cosine of 30. Try it on a calculator. Who's got a calculator out? You love your calculators, right? Get them out and punch it in.
What do you want me to do?
Put the cosine of 60, see what you get.
Okay.
And then put the sine of 30, see what you get. You get the same exact thing, don't you? Try this. Try the cosine of 30 this time. You get like 0.86 or something like that, right? Okay. Try the sine of 60, see what you get. Same exact thing. All right?
Math is fun.
It is fun. I'm not kidding. Well, I'm not kidding.
That's why I like to do.
It is fun.
Hey, can we get our worksheets spelled in a minute?
It sure does.
Where are you in the worst?
To eat lunch, my tummy's burning.
All right, let me give you a worksheet. I'm going to still go over some more of these tomorrow, but try to at least get done the amount that we did today in class, and I'll review some of that other stuff tomorrow. I want to make sure that you get this stuff.